The next thing we're going to talk about are batteries and fuel cells. And there's two main types of batteries, primary and secondary. And then there's this idea of fuel cells. We'll cover all of them. Primaries, batteries, refer to those that are non-rechargeable. And you've probably heard of a couple of types in your life. One of those is a dry cell, and the other is alkaline. And what I've shown here are the equations and diagrams, a schematic of each of those. So you can see for a dry cell, we've got manganese dioxide, and it's reacting with ammonium chloride and zinc to give you a reaction. And if you look at the diagram on the side, you can see where each of those reactants comes into play. Note also that the zinc gets involved with the reaction, but is also used as a casing. Very clever engineering. Likewise, the dry cell, it has no liquids, hence the name dry cell, to state the obvious. There's also alkaline batteries that do not have liquids, and you can see the diagram on the right there. It's a reaction of zinc and manganese dioxide. So let's now go and take a look at the secondary types of reactions. You've probably heard of all these NiCad or nickel, cadmium, and lithium ion, and the good old lead acid battery, our car battery. The NiCad batteries, there's the reaction for those. The lithium, I'll also show you you can also see the reaction for that one. Lithium batteries, when I went to China, they made me sign a form that said I did not have lithium batteries. They are known to explode and cause problems. And I don't really expect you to memorize these equations, but I do particularly want you to understand the last one, and that is the lead acid battery. Given that it is so important, it is the car battery. So what happens here? One thing I want you to notice is that two different forms of lead form lead sulfate. They make the same thing. Lead is converted into lead sulfate, and lead oxide is also converted into lead sulfate. So let's take a look at what happens in the reaction that produces the electrons that go through your starter that starts your car. Of course, your car starter is going to be where that light bulb is shown there. What happens is lead is converted into lead-2 ions, and those lead-2 ions then pick up sulfate from the solution to make lead sulfate. Meanwhile, the electrons travel through your starter to the other side of the battery, and there we have a reaction of the lead oxide with 4 moles of hydrogen ion. It uses 2 electrons from the water, from the lead oxide to make the water, and it gets the other 2 electrons from the lead, making lead-2 ion, which then pulls sulfate from the solution and makes also lead sulfate on that side of the equation, at that electrode as well. So there's your illustration of both electrodes forming the same product and water. What happens when you charge your battery, which in your car, of course, that's done with the alternator. As you run your car, it charges your battery, and your alternator serves as an electron pump, in essence forcing the electrons back the other way. And what essentially happens is all of those reactions you saw on the discharging side are now reversed, and the battery is recharged. Moving on to the fuel cell, this was the great hope. It's a way to react 2 basic elements, hydrogen and oxygen, and to produce an exhaust which is nothing more than water. The ultimate and environmental friendly. At one electrode, hydrogen is oxidized to water. At the other, oxygen is reduced to water. Your byproduct, of course, being water. If it's so great, why aren't fuel cells everywhere? The engineering is quite a challenge, as well as the cost, because your raw materials, pure hydrogen gas and pure oxygens. It's pretty tough to engineer those in a safe and economical manner. but great hope nevertheless. And with that, you've had a look at your basic batteries and fuel cells.